All right, this video is going to have a few notes for systems with simple elimination. Make sure you're thinking about simple elimination here because the one that is systems with elimination requires an additional step that you can learn about in another video. But simple elimination, the essential question is how can adding or subtracting two equations help me solve a system of equations? So if you need to pause to write that down, go ahead and do so. And we're going to try to take some notes that answer that essential question. So I'm going to start with this question here. What are the important facts? And there's a couple of background facts you need to know for this particular skill. And so the first one is the addition property of equality. So the addition property of equality says, and I'll write the definition maybe in another color, addition property of equality is that if you add the same thing, I'll write it this way, you add equal values to both sides of an equation, the new equation you get is also a true equation. Okay, so the addition property of equality is this fact that you guys learned about for several years now. I'll give you an example. The example is if I have x plus 2 equals 4, if I take away, or sorry, add 2 to both sides of the equation, I'll get x plus 4 equals 6. If this equation is true, the addition property of equality says that if I do this, this is also true. You can see maybe a more straightforward example if we don't use any variables, so I'll give you a second example here. The second example that we're going to use is the following equation. If I have 2 plus 3 equals 5, if I add 2 to both sides of this equation, I'll get 2, I gotta scroll down a little bit, 2 plus 3 plus 2 equals 5 plus 2. And so I can check that. 2 plus 3 plus 2 equals 7. 5 plus 2 equals 7. So I started off with something that was true. I did the same addition of both sides, and so I get a result that's true. The addition property of equality extends so that you can subtract the same thing from both sides of an equation. And so we're going to use that fact. There's an additional fact. Sorry. I'm going to scroll this thing down. There's one more fact that we need to look at here, and I'll write it in black again. A system of equations is two or more equations that both, I'll say all because I put were all, that all need to be true if you have a solution. And now that may seem or feel a little bit cryptic at this time, but I'm going to go through some examples that will help you out with that. I'm going to go ahead and scroll down. We're going to do an example from Khan Academy. Give me just a moment. So we're going to start with this next question, what is the process? And I'm going to kind of divide this into two sections. This is going to be the description. So I'm going to try to describe the steps I take, and then this is going to be an example. So I'm going to take this example that you see over to the left there. So the example is going to be negative 3x plus 3y equals negative 6, and negative 5x minus 3y equals negative 50. Okay, and so I'm looking at this equation. I'm going to notice something. You don't have to write this part down, but I just want to say a couple things. I'm noticing that plus 3 and minus 3 in terms of the y's, they're totally opposites. If I take positive 3y and I add negative 3y to it, I should get 0. And we're going to use that fact here in just a second. So let's think back to something that we wrote just a minute ago, and that is that if you add equal things, equal values or expressions to both sides of an equation, the new equation you get is also a true equation. And so here I've got equation 1, and then I've got these two things that are equal. There's two things that are equal. Negative, whoops, I needed a highlighter there, not a line. This 5x minus 3y is equal to negative 50. And so those are equal things. So if I add those things to the top equation, I should get another true equation. And so I'm going to do that. I'll do this step in blue. So I add these two equations. I'm just going to add the like terms. And so I have negative 3x plus a negative 5x is going to give me a negative 8x. Plus 3y and minus 3y, they're going to give me 0y. And negative 6 plus a negative 50 is going to give me something that equals negative 56. Okay, so I'm going to look at this. If I have 0y, that's the same as 0. So this is the same as negative 8x plus 0 equals negative 56. And then I can think to myself, well, what does 8x plus 0 really equal? Well, it equals just 8x. Negative 8x equals negative 56. And I want you to notice what's happened before we summarize this here. So we took two equations that look rather complicated. We added them together. The y variable dropped out because it became 0, and it left me with an equation that's just x. And so this is, if I have something that's true and I add equal things, I should get something that's also true, just like our examples above. And so now I have this equation that looks a lot less intimidating. I'll do this step in red. I'm going to divide by negative 8, and I find that x is equal to positive 7. All right, so when I am looking at this, my equation started out with x and y, and so if you think back to this definition of a system of equations, it's two or more equations that all need to be true if you have a solution. In order for both equations to be true, I need to know something about both x and y. And so I'm going to do a little bit more work in order to find y, and I'll do this step in green just to distinguish it. Okay, so what I'm going to do is I'm going to take this x value, I'm going to put it back in one of the original equations. So if I have negative 5x minus 3y equals negative 50, I know what x is now, and so I'm going to put it in there. It's going to be negative 5 times 7 minus 3y equals negative 50. And the beautiful thing that happened again is that I no longer have an x in this equation, I just have a y, which I can solve for. And so I'll multiply and get negative 35 minus 3y equals negative 50. I'll add 35 because it's negative and I want to get rid of it. I'll end up with negative 3y equals negative 50 plus 35 is negative 15. And then I'll divide by negative 3. And so y equals 5. All right, so now I have an x and a y, which I could write as an ordered pair if I wanted to. And if you've done the graphing solutions to systems, or graphical solutions to systems, you'll know at this point that if you have a coordinate pair, that's the point at which they intersect. So those two lines we started with, that's where they intersect. And I can report that solution to Khan Academy, and I may do that in just a minute, but I want to do a little bit of reflection on this process first. And so in my description column over here, hopefully you left room, the first thing I'm going to do is add or subtract the equations to get rid of one variable. And so if you look back to our work here, we added the two equations and it got rid of y because plus 3 and minus 3 became 0. The next thing I do, and this is the step that's in red, is solve the new equation. And so if I look at my work here, I had negative 8x equals negative 56, so I just divided to solve and find x. And then the last step I took was plug the value in to one of the original equations. And it doesn't matter which. And last, solve again. So it's basically a four-step process, and there's this important question we can ask, and how do I know when I'm done? First, how do I know when I'm done? The first way that you're going to know that you're done is that you have an x and y answer. You have to know both x and y. And then the second way you can know you're done, your x and y work for both equations. And so I'm going to show you a way to check that here. And so I have this 0.75 that I think works. And so I'm going to check to make sure it works in both equations. So the first thing I'm going to do is I'm going to look at the first equation, negative 3x plus 3y equals negative 6. I'm going to plug in for x and y with 7 and 5. So this is negative 3 times 7 plus 3 times 5. And we're curious whether or not that actually equals negative 6. So this is negative 21 plus 15. That indeed does equal negative 6. Negative 21 plus 15 equals negative 6. So it works for the first equation. It makes something true out of it. Let's check the second equation. I start out with negative 5x minus 3y equals negative 50. And so I'm going to plug in for x and y. That's negative 5 times, I'm going to plug in 7 minus 3 times 5. And then the question is, does that actually equal negative 50? And so this is negative 35 minus 15, and that does indeed equal negative 50. So it works for both equations. And so I can write it's the solution because it makes both equations true. All right, so we've worked an example. We've taken quite a bit of notes over this. And so at this point, you need to make sure that when you are done watching this video, that you take a moment and figure out an answer to this essential question. And so this question, how can adding or subtracting two equations help me solve a system of equations? I need you to try to write a summary that answers that question down here in this summary section. And if you can do that and you've taken the notes, I'm certain that you're going to be able to clear this particular objective pretty quickly. Of course, if you need help, all you have to do is ask.